Okay, yeah. Hello from me. I'm Klara. I'm also working in the group of Annette Eicker, and I want to give you some insights about my research topic. And the overall goal is the evaluation of climate models by using satellite gravimetry. And one quantity that can be used for this evaluation is the intensity of extreme events. And why are we interested in extreme events? I think we all heard about extreme weather events a lot lately. Like every summer we hear about new heat records or about droughts and wildfires. And on the other hand, we also hear a lot about heavy precipitation events or floods. And in this context, always when an extreme event occurs, it is said that climate change leads to an intensification of the intensity and the frequency of extreme events. So how do we know? And it is also said that in the future this will even increase. So, but how do we know that in the future extreme events will occur more often and that it is linked to climate change? And for this, climate model simulations can be used. Climate models simulate processes and interactions of various variables that are part of the Earth's dynamic system and predict their future evolution. And to predict their future evolutions, different scenarios are assumed. For example, here you can see 4 different scenarios for the global CO2 concentration. And yeah, so the climate model simulations have many different variables as output, and I'm particularly interested in variables that are referencing to the terrestrial water storage. So if we combine these variables, we get like the model terrestrial water storage. And as you have heard already in the presentations from Annette and Viviana, we can also use or GRACE, like satellite gravimetry, observes terrestrial water storage because it observes changes in the Earth mass distribution, which is mainly caused by changes in water mass. So now we have modeled terrestrial water storage and observed terrestrial water storage, and this we can then compare the extreme events from both, but we can actually not compare the time series directly, like different time intervals, but we need to apply statistics like extreme value theory. And because I run out of time, I just want to show you shortly how this looks like. Like with the extreme value distribution, we can calculate a quantity that gives us a measurement for the magnitude and intensity and frequency of extreme events, which we can then use like to compare the data from the modeled and the observed terrestrial water storage and also see if there are changes in long-term simulations. Thank you.